I'm Phil, and today I'm going to have a look at the Elecfreaks CuteBot Pro. It's a robot for STEM education, and it uses the microbit computer. So let's have a look. We'll just move our mind map across, and I'll give you a look. Here we go. This is what it looks like. And it comes with the ultrasonic rangefinder, which you can see on the front. And we've got the microbit just behind that. So it's a two-wheeled robot with actuators, encoder motors, and RGB LEDs. Sensor-wise, it's got the encoders can be used for distance measurements, and it has a built-in algorithm using PID for reasonable distance calculations and following those distance specifications. I think it's got a gyro, but I can't get much documentation on that. And that helps with the stabilizing. It does line following and communications. You've got a infrared receiver. Okay, the cost-wise, you can get this at discount. It's a bit expensive at $62.50, but the discounted price, just under $50, is a bit more reasonable. And it's cheaper than the competitors. So we'll have a look. It doesn't come with a battery. You have to buy that yourself. Comparison, well, I guess its closest competitor is the DF Robot McQueen Plus version 2. So in price-wise, they're about the same price. And the McQueen allows you to add, there's more mechanical support for additional devices. So if you want to do that, that's might influence your decision. We have a look at the hardware-wise, the block diagram for the robot. It's quite small, not a lot of room for extensions, but we'll have a look at extensions in a minute. So it comes with plenty of ports for adding additional sensors and actuators. Spec-wise, we've seen most of that before. And we'll have a look at what's in the kit. This is what you get when you purchase it. And if you want to extend it, you can either get the add-on blocks pack, and that allows you to use these Lego components and build all sorts of interesting devices like the gripper or the catcher trolley, or you can add other AI devices to the CuteBot Pro. And or alternatively, do what I've done. I had all of those Lego components, and you just need to have screws for that. And what I found, the best Lego components are the frames, the A-frame, the beams, and you can get those in packs at AliExpress. But if you do that, you need to get standoffs. I'm using 20mm length brass standoffs, and you need to get the right screws, Phillips screws, flathead, 12mm, and they'll go through the A-frames. Okay, well, so much for the hardware. Let's have a look at the software. And software-wise, we're using MakeCode, and the extensions. Well, there are two extensions I'm going to use on my projects. Most important comes from Elecfreaks, and that's for the CuteBot Pro. And there are plenty of commands there that you can use for your program. I'm also using a time of flight rangefinder, and we'll see that working on one of my projects. So the projects, I bought the robot because it was advertised by Microsoft as being compatible with the MateCode simulator for robots, but the simulator doesn't work properly on this robot. So that's a bit disappointing. But everything else works quite well. I've got it to move along a line, track a robot map, and I'm able to use the mate code to get that to work. And it worked quite nicely. So there's the code for that. And we might go across and have a look at that now. So here's the code for our robot path program. So when you press button A on the microbit, you select the path, and the maximum number of paths are specified right at the beginning. Here I've only got 2 paths, and each path is handled by a function. So we've got path 1 or path 2. And in this program, we've got, let's have a look, we've got the button B will select the particular path and go to that path. And what we're doing here is turning on the headlights and then either turning 90 degrees left or right, and then moving forward. So we're moving on a grid in the using the DF robot map. So here's our routes for the CuteBot Pro. We're going to start on the bottom left at point number 1. Then we're going to take a left-hand turn at intersection 2, move along till intersection 5, then move right, and then right again, and we'll end up at our target A. So that's our first path. The second path, we end up at B. So we've done this before with the McQueen, and we'll show you how the code is modified. This is the McQueen code, and this is the code for our CuteBot. So we're not doing intersection control. This time we actually have to measure how long it is between intersections. And we either give a forward instruction with a distance, or we turn left or right. So this is for path 1. And for McQueen, for path 2, we have a similar sequence of commands for CuteBot Pro. So I was happy with the results, and we were able to get the robot to drive along a Pacific route. In this case, there are 2 paths, path number 1 and path number 2. And it excelled quite well at that task. The next project is to add a catch to CuteBot. And this is the catch that I've added. The catch actually comes from a component from M5Stack, and it uses Lego components. And I've added a Lego A-frame with screws to mount onto the CuteBot Pro. So the objective here is to use either an IR remote or the microbit buttons to control the catch. And I'm going to show the results also on the microbit LED array. So the components for this are the microbit, the CuteBot Pro, the M5 catch unit, and there's a description of what that looks like and how it connects electrically and mechanically to CuteBot Pro. And I'm also using a IR remote controller to test the communications with the handheld IR remote and CuteBot. Software for that, well, the code is quite simple. I'm showing the movement of the catch on the microbit LED array, and at the same time, when I pick up the code, I move the catch, either close it or open it. And the results of that were quite good. I was able to get it to open and close the catch. So that was another successful project. So for communications, I've already tested the IR. It works quite nicely. And the other project that I worked on was adding another M5Stack component. And this time it's the time of flight. So when you add the catch, you take up the space that was previously occupied by the ultrasonic rangefinder. And here I'm using Lego components again. And there are two locations you can mount that. So the top location, or right on the front, we've got the M5 time of flight. And in this project, I'm going to see how consistent and accurate it is. This is an alternative arrangement where you could mount that. It's a little bit higher, and it mounts on a couple of posts. So we might go have a look at what the objective. We're going to test the M5Stack time of flight laser rangefinder on the CuteBot Pro. Hardware-wise, similar to what we had before, but we're adding the time of flight. And this is the details of that. We have to add an additional extension, and that's the rangefinder. And once we do that, we've got a couple of commands we can use, and you can see the program. The program is actually very, very simple. It just initializes on startup the time of flight sensor, and in forever, we capture that range to our target, and we show that on the microbit LED array. So I was happy with the results on that. And the accuracy, you can see we've got a pretty good line that goes from 100 millimeters up to 700 millimeters. And this works within about 1.2 meters if you want reasonable accuracy. Okay, so quite happy with the results on that. Okay, we might go and have a look at the critique for this robot. So they're the projects, and they all worked out quite nicely. Okay, so what are the good and the bad points? We might increase that so you can see it. Good parts are that it does cover some of the more advanced concepts for PID control. That's quite easy to use when you do that. The disadvantages that while it's doing PID control, there's no internal details of what's happening. You can't control the coefficients of the PID algorithm yourself. A nice thing, it's value for money. It's a lot cheaper than the DF robot equivalent, the McQueen. Software-wise, you've got good support there in the make code extensions, and very suitable for STEM education with minimal additional effort needed to get those advanced concepts. Construction-wise, fairly well built. You can assemble it very quickly. Perhaps definitely within 10 minutes, you should be able to assemble the whole thing. Power-wise, you've got an indicator, and the battery is big enough so it'll last for a whole afternoon session, and you can recharge it overnight. There is plenty of access to extra ports if you want to extend it. The line detection is good, and it's got good mechanical support. Documentation-wise, both the tutorials and the examples are quite good. Okay, are there any bad points? Documentation is very little on the ports. There's enough to get going, and as long as you don't want to do anything complicated, you can add additional electronics and ports to that. The mechanical, the technical description, it's not supported by the Microsoft MateCode for robots, and that's quite disappointing. You're on your own with MateCode. There's no other IDE available, so there's no libraries for the Arduino IDE, and there's nothing on the PID. I haven't tested it on Python, but they claim it does work. Recommend. It's okay, particularly if you're on a limited budget and you want to do simple projects, but perhaps you want to veer into some of the more complex. And the disappointment was it doesn't work with the MateCode for robots. And if you want to get references on it, go across to the Elecfreaks website, both the shops. We might go there now and have a look at what it looks like. So here you can see the advertisement and the web page for the CuteBot Pro, and there's a very good wiki on that link. Quite a lot of projects where you can follow and construct to start before you start your own construction. And that's it from the Elecfreaks CuteBot Pro. This is the CuteBot Pro Robot by Elecfreaks, and it uses a microbit as its controller, and it has two main sensors. There's a sonar, and under the robot we've got the 4 line followers sensors, and we've also got a gyro, and that assists with a PID control. And what we're going to do is just demonstrate the line following using PID control. So we'll start the robot with button A. And there you can see we're getting quite a smooth motion from the robot. And what we do, we just use the palm of our hand, and the ultrasonic sensor senses the position of the of my hand and stops the robot. This is CuteBot Pro from Elecfreaks, and we're going to navigate our path to our targets. So when we press button A, we'll select the path, and we start the journey on button B on the microbit. So here's our target A and our target B. So let's go and start. So we've got route number 1, and we'll start. And it's successfully completed the first route and ended up in our target A. We're currently on target or path 1. To select path 2, we press button A, and it shows the path number, and we start the path by pressing button B. And CuteBot Pro has arrived at our target. Here we have CuteBot Pro with a time of flight sensor. This is a laser sensor from M5Stack, and it goes into the eye to C bus. And what we're going to do is look at the accuracy as we go along the scale. So the first measurement at 100 is 110, and we'll move our obstacle to 200, and we get a reading of 210, and then we'll move it out to 30. So here's our obstacle and our time of flight sensor. So at 30 we've got 310, 310, 320, and we'll go out to 400. So we're at 400, and we get a measurement of 409, and we go to 500. 511, 493, and we'll go to 600. 630, 594, 603, and finally we'll go to 700. So the reading at 700 is 691, 615, 689, 689, and that's the calibration and the measurement of distance using a time of flight sensor.